Why higher current is not always dangerous. Electric current is often spoken about as if it is dangerous by nature. The moment the term high current is mentioned, it creates fear of electric shock or accidents. Over time, this fear turns into a simple belief. If current increases, danger must increase as well. The idea sounds logical, so it is rarely questioned. But electrical systems operate on precise rules. This belief comes from real experiences. Burnt wires, blown fuses, sparks, and warning labels leave a strong impression. These moments teach caution, but they also blur an important distinction. They make it seem as if current itself is the problem, rather than the conditions under which current is allowed to flow. In reality, current is simply the movement of electric charge. It does not decide where to go, and it does not increase on its own. Current flows only when a complete electrical path exists, and it always responds to the properties of that path. This means higher current, by itself, is not automatically dangerous. Many systems around us operate safely with currents far higher than what the human body could tolerate. Homes, machines, and power supplies all rely on continuous current flow without causing harm. These systems remain safe not because current is avoided, but because it is controlled. Electrical safety is defined by how current is guided, limited, and contained. When current flows through a designed path, it performs useful work instead of causing damage. Resistance plays a critical role in this process. Resistance limits current and prevents it from rising beyond safe levels. Every electrical device depends on resistance in some form. It is not a weakness of electrical systems. It is one of their primary safety mechanisms. This is why appliances can operate for hours without overheating or causing injury. Current flows continuously inside them, but the path is designed to handle it. Heat is managed, exposure is prevented, and energy is converted into useful output. Danger appears when this control is lost. When resistance drops suddenly, insulation fails, or a designed load is bypassed, current can increase rapidly. The problem is not current itself, but the loss of limits that normally keep it safe. A common example of loss control is a short circuit. In a short circuit, current finds an unintended path with very little resistance. Energy that should do useful work turns into heat instead. Wires overheat, insulation melts, and components fail. The damage caused by a short circuit is real, but the cause is often misunderstood. It is not simply high current. It is uncontrolled current. This is why protection devices exist in electrical systems. Fuses, circuit breakers, and protective devices do not stop current from flowing normally. They stop current only when it exceeds safe limits for a specific path. Their role is to restore control when something goes wrong. The human body adds another layer of complexity. Unlike electrical equipment, the human body is not designed to carry current. Its resistance changes with skin condition, moisture, contact area, and the length of exposure. Because of this, even relatively small currents can become dangerous if they pass through sensitive parts of the body. Electric shock is unpredictable because it depends on the path the current takes, not just the amount of current involved. This unpredictability helps explain why the myth about current survives. People see shocks, burns, and failures, but they do not see the conditions that cause them. Current becomes the visible culprit, even though it is only reacting to its environment. Once this distinction is understood, electrical safety begins to look very different. It is no longer about avoiding current completely. It is about ensuring that current flows only where it is intended to flow. This understanding explains everyday observations. It explains why thick wires can be safe, why appliances operate continuously, and why grounding and protection systems exist. Careless connections are often far more dangerous than high ratings on equipment. The real rule of electrical safety is simple. Danger is not defined by current alone. It is defined by the path, the resistance along that path, the duration of exposure, and whether the system is designed to handle the flow. When these factors are respected, current becomes predictable and controlled. When they are ignored, current becomes destructive. Electrical engineering is not about eliminating current, but about managing it properly. So when the phrase high current creates fear, it helps to pause. The more important question is not how much current exists, but whether it is controlled. Once this is understood, electricity becomes logical rather than frightening. This is the point where myths give way to understanding. Electricity stops being mysterious and starts making sense, not as something to fear, but as something that follows clear and reliable rules.